10 mind-blowing scientific facts about black holes. Black holes are the only object in the universe that can trap light by sheer gravitational force. Scientists believe they are formed when the corpse of massive star collapses on itself, becomes so dense that it warps the fabric of space and time, and any matter that cross their event horizon, also known as the point of their return, spirally helplessly towered as unknown fact. Despite decades of research, this monstrous cosmological phenomenon remains shrouded in mysteries. They are still blowing the minds of scientists who study him. Here are the 10 reasons why black holes do not suck. Number 1. Some think that the black holes are like cosmic vacuums that suck in the space around them when, in fact, black holes are like any other object in space, albeit with a very strong gravitational field. If you replace the sun with a black hole of equal mass, Earth would not get sucked in. It would continue orbiting the black hole as it to orbit the sun today. Black holes, like they are sucking in matter from all around, but that common misconception component stars shed some of their mass in the form of stellar wind, and the material in the wind then falls into the grip of hungry neighbor of black holes. Number 2. Einstein did not discover black holes. Einstein did not discover the existence of black holes, though the history of relativity does predict their formation. Instead, Carl Sagan was the first to use Einstein's revolutionary equations and show that black holes could indeed form. He accomplished this the same year that Einstein released as the theory of general relativity in 1915. From Schwarzschild's work came term called Schwarzschild radius, a measurement of how small you do have to compare any object to create black hole. Number 3. Black holes will spectrify you and everything else. Black holes have the incredible ability to literally stretch you into a long, sector-like strain. Appropriately, this phenomenon is called spectrification. The way it works has to do with how gravity behaves our distance. Right now, your feet are closer to the center of Earth and are therefore more strongly attracted than your head. Under extreme gravity, say near a black hole that different in rotation, attraction will actually start working against you. As your feet begins to get stretched by gravity's pulls, they will become increasingly more attracted as they inch closer to the center of black hole. The closer they get, the faster they move, but the top half of your body is further away and is so not moving toward the center as fast. The result is spectrification. Black holes could spawn new universe. It might sound crazy that black holes could spawn new universe, especially since we are not sure other universes exist, but their theory behind this is an active field of research today. A very simplified version of how this works is that the universe today, when you look at the numbers, has some extremely convenient condition that came together to create life. If you tweak these conditions by even minuscule amount, then we will not be here. The singularity at the center of black holes break down our standard law of physics and could, in theory, change this condition and spawn a new, slightly altered universe. Number 5. Black holes literally pull the space around them. Picture space is a stretched rubber sheet with criss-crossing grid lines. When you place an object in the sheet, it sinks a little. The more massive an object you put in the sheet, the deeper it sinks. The sinking effort destroyed the grid lines, so they are no longer straight but curved. The deeper you make in space, the more space distorts and curves, and the deposit of walls are made by black holes. Black holes create such a deep well in space that nothing has enough energy to climb back out, not even light. Number 6. Black holes are the ultimate energy factories. Black holes can generate energy more efficiently than our sun. This work has to do with the disk of material that orbit around a black hole. The material that is nearest to the fringe of the event horizon on their inner edge of the disk will orbit much more quickly than material at the very outer edge of the disk. This is because the gravitational pull is stronger near the event horizon. Because the material is orbiting and moving so rapidly, its heat up to billions of degrees Fahrenheit, which has ability to transform mass from the material into energy in a form called blackbody radiation. To compare, nuclear fusion convert about 0.7% of mass into energy. The condition around a black hole convert 10% of mass into energy. That's a big difference. Scientists have proposed that the kind of the energy could be used to power black hole starship of the future. Number 7. There is a supermassive black hole at the center of our galaxy. Scientists believe there is a supermassive black hole at the center of near every galaxy, including our own. These black holes actually encode galaxies, holding them together into the space. The black hole at the center of the Milky Way, Sirius A, is more than 4 million times more massive than our sun, although the black hole, which almost 30,000 light years away, is pretty dormant at the moment. Scientists believe that 2 million years ago it orbited in explosion that may have even been visible from Earth. Number 8. Black holes slow down time. To understand why, think back in the twin experiment that is often used to explain how time and space work together in Einstein's theory of general relativity. One twin stay on Earth while the others zoom out into space at the speed of light, turn around and return home. The twin that travels through space is significantly younger because the faster you move, the slower time passes for you. As you research the event horizon, you are moving such high speed due to the strong gravitational force from the black hole that time will slow down. Number 9. Black holes evaporate our time. The surprising discovery was first predicted by Stephen Hawking in 1974. The phenomenon is called Hawking radiation after the famous physicist. Hawking radiation disappears a black hole's mass into space and our time and will actually do this until there is nothing left, essentially killing the black hole. This is why Hawking radiation is also known as a black hole evaporation. Number 10. Anything can become a black hole in theory. The only difference between a black hole and our sun is that the center of black hole is made extremely dense material, which gives the black hole a strong gravitational field. It is the gravitational field that can trap everything, including light, which is why we can see black hole. You could theoretically turn anything into a black hole. If you shrunk our sun down to size of only 3.7 miles, 6 kilometers across, for example, then you would have compressed all of the mass in our sun down to incredible small space, making it extremely dense and also making a black hole. You could apply the same theory to the earth or to your own body, but in reality we only know of one way that can produce a black hole. The gravitational corpus of any extremely massive star that 20 to 30 times more massive than other sun.